Welcome to the online session, SKS Scalable Kubernetes Service. I am very happy that we were able to attract such a large number of participants today. We have prepared some exciting topics for you. After introduction of overview by COO and co-founder Antoine Corsier, we get into the topic why Kubernetes benefits of SKS in a container world with my valued colleague Hans Berndl. After that, Dennis Arnst will show a live demo in the Exoscale platform. Afterwards, Philipp Möller will give you a summary of our feedback from the beta testing phase in the voices from beta tester. And finally, we will answer your questions in a Q&A session. I would now like to hand over to COO and co-founder Antoine Corsier, who oversees the business and operational aspects of the Exoscale platform with his 20 years of experience in the service provider business. I hope you enjoy the online session. The stage is yours, Antoine.
Hey, good morning, everyone. Thank you for joining and giving us an hour of your time this morning. So we'll try to keep this really on the, as presented on the schedule. And already, I really want to say thank you. We had more than 200 registrations for today's event, which is not the usual setup that we've used in the past for Exoscale launching. And today I see already, yes, more than 150 people already listening. So thank you for that. Thank you for giving us some time today, precious time. I'll start with a quick recap. 2020 was, unlike many businesses, the cloud segment went well, and that was true also for Exoscale. In 2020, we tripled our growth. That was outstanding. Of course, some projects were canceled due to the pandemic, but a lot of businesses had to go online, had to push additional content applications and etc. to enable their workforce to continue working. So we helped in that regard. And 2022 was a busy year for us. We did a lot of product feature upgrades, also new products. We launched our network load balancer, which was a long-awaited piece. We launched a CDN, so Exoscale CDN was introduced, and did a lot of refinements towards templates, towards the way we manage the keys in API keys in the platform. That being said, still a nice growth, but the COVID pandemic was still a situation for us as a company that was already working with a remote setup. It was still not easy for us, as we usually do off-sites with our employees so that we can bond together and really start in those events shaping the future of the product lineup and the company. Missing on those important aspects of social life and bonding were hard for us. But still, we are, as the management of Exoscale, very proud of what our team was able to accomplish, because today what we're presenting as SKS, there's a year's work of development and joint forces from our team in that difficult setup. So again, thanks to them. We hope that we'll deliver on quality, and I hope you will see that again we focus on simplicity with this new product, and it launches with everything end to end for you to manage Kubernetes clusters. I hope this is also the start of a new acceleration for Exoscale. This product we launched today is one of a long list. We hope to be for 2021. We'll try to introduce additional products. So registry service, database services also are in the lineup. So stay tuned in the months to come to hear from us with additional items. Now I will hand the floor to aren't, because we are going to give you content for the wide audience we have today. So going from a general introduction about Kubernetes, how do we see and what's the Kubernetes strategy at Exoscale, and then for the more technical savvy people, go with a full demo. So bear with us a few moments. We have content for everyone.
Yep, thank you, Antoine. Hello and welcome. My name is Hans Bernl. I take you on the first tour of today, and I structured it by 3 guiding questions because to get on the right direction and covering the 2 topics at the beginning, the most important question is why. So why containers, why Kubernetes, why managed Kubernetes, and I would like to take you on that journey. So let's get started. Why containers? If you've been in IT for a long time, you have seen probably many concepts, and container is a new one. And why that's so important for us? First of all, I've spent many years already, and I've been in different roles. There are some IT experiences I think we all want to change. And normally at large events, you have those shiny, happy people. We start with the not so shiny and not so happy people because that's exactly what we want to address in our industry. So if you have been a system administrator, like I've been, and you got woken up at 3 a.m. in the morning to restart a process, to restart a program, that's not of your favorite moments in your work life. Or if you have been a developer and you brought your code into production only to see that it's not working like on your development workstation or on your laptop, it's another experience you certainly want to change. And if you're a system architect and you do load tests and you mistakenly, because of the complexity you already reach with your system, put that load test on a production server, you probably make faces like you see here, and you're also not very happy about that. So containers and the technology around containers gives us the opportunity to change all that. And how does that go? We will look into that in the next minutes. So as usually in IT industry, we take good ideas from others and make it our own. The same is true for container. Container technology is more or less from the transport or for the shipping industry. They came up with the idea to optimize. So thinking about a way to ship a product every time you want to ship a product is not very efficient. So if you come up with a standard, and the standard was the steel container, were optimized for loading a lot of those steel containers, and you have the cranes in the harbor who can really quickly load and unload those containers onto lorries, onto trains, and you have this end-to-end transportation. So it's efficient, you optimize. Compatibility is a topic in there, standards, so you can make transport way more effective. These are all things which are also applicable into IT matters. If you look at it, container technology in the IT industry addresses similar stuff like in the shipping industry. So you talk about increased compatibility, reduced dependencies, and you have a smoother develop, deploy, and operate mode, which we all like to achieve, because if the applications run smoother, then you don't have the administrator who's woken up at 3 a.m. In the morning. If the development, deploy, and operate is smoother, you have more happier developer because they see their code running as they have seen it on their laptop, because basically they're running in the same environment, but it's a different scaling behind it. And if you've been long around and you had DLL hell and stuff like that, and it means something to you, then this new approaches and using container technology is really easing burdens we all had in the past to overcome situation where we are not so happy in our industry, in our job. And that's why container will be, because I think we're still in a transition phase, but it will be a much greater success than it already have been, but also the complexity it comes with, we have to deal with. That's also a topic of today. So my statement is the future is in containers. Maybe a little bit always exaggerating, but nevertheless, it's a bold statement. I think it's to a certain degree true. If you look at the tradition, the history of IT, if you're sitting in front of physical servers in a data center, pulling out your tray and with your keyboard and your monitor, and you were installing software there, because at the end, what we want to do is running apps. It was always the goal, having the apps. It wasn't always called apps. Maybe before it was called programs, and now it's application or apps. But it was the application the focus. And when we did that in the old days and directly installing the operating system to the hardware, and on that installation, then we installed our application or application service. There were some technical limitations, so you couldn't, you could install all kinds of application on one system, but there was some learning that you had dedicated roles. You had your email server, you had your database server, you had your file sharing server, your print server, and stuff like that. And if you looked at the overall performance and the utilization of those systems, the sad story was it was only utilized around 10% or below. So the financial people were not so happy because they paid 100% for that equipment, and we used it on average only 10%. So the next big step at the beginning of the 2000s was, okay, we do virtualized server, because we want to increase the efficiency of the utilization of the hardware underneath it, which is still there and all that concept, to get a better degree of using what we paid for. And it's quite complex there as well, but we get a better usage of our equipment. We simulated the whole physical machine in software. For that, we used a magical part of software, which is called hypervisor, and it's handling all the resources and handing that over to the virtual machines. That made life a little bit easier and more efficient, as we all know. Even though some people at the beginning of the 2000s didn't take that route of server virtualization. One of them was Google, and they invented something which we now know as container technology and also as container orchestrations, because they had a different type of application and a different running those applications. To what we know as this container and container orchestration. Because on a typical setup, you could run a couple of virtual servers depending on the hardware underneath it, of course. So dozens in that dimension. But if you look on the container deployment scenario, you could have hundreds and thousands of containers, and the startup time and the availability of containers is much quicker than what you can do with virtual machines. Even though on Exoscale we are really quick with providing virtual machines, container is the next booth in regards to performance and speed. And that's what's dominating our world today. Everybody is using apps everywhere, and everybody is expecting apps running 24/7 uninterrupted. And getting there, you need different types of deployment, different types of operation, and different types of technology underneath it. And container is a kind of answer to that. So answering the question, why container? Because basically we need it to run apps like we want to run them, and what our customers are expecting from the apps and their availability. So the next question to structure our journey is, why Kubernetes? So we have this great stuff now, containers, and we understand how to use them, why to use them, and that they are really a better way to do it. But if you start using them and you start running your services in container, then something happens pretty quick. You have a lot of them, and not like the virtual server, so a dozen and 2,000 on your hardware. You have hundreds and thousands and even more. If you look at Google, who invented that stuff, basically, because they needed it, millions of containers. And if you do that, then typical tasks you do in IT start becoming very difficult. So scaling up your services without any additional help of container orchestration software it's a lot of manual work, and that increases, and all increases of that type of work increases also cost at the end, and also the complexity of running those scenarios, this new type of applications, which most of the time has a microservices architecture, so that you can really distribute that service in many small chunks, which makes it so flexible on the one hand side, but also complex on the other hand side. And if in that system something starts crashing, or you have to fix crashing nodes and do that manual, that increases also your workload tremendously. Therefore, you need more human resources, you need more educated, more knowledgeable people, so that increases as well. Overall, without any specific help in that scenario, scaling becomes difficult. And if you don't manage your resources efficiently because you don't have the right tool at hand, then your resources, even you could run containers on premises, of course, but most people now tend to do it in the cloud. So your public cloud provider bill becomes more and more expensive. We are public cloud providers, so we could say that's a good thing, but we don't do that because we want to provide you with a solution and resources that you are satisfied with your operation and with the usage of the resources which are optimized for your applications. So yes, we need something that helps us to run those more complex environments to provide our applications with more performance, more reliability, and therefore is one of the solutions is Kubernetes. To explain that is not always easy. That's why I was looking for a simple way to explain what does Kubernetes. So basically Kubernetes in plain English. And the former executive director of the Cloud Native Computing Foundation, who sadly passed away at the end of last year, Dan Kohn, could put that all together with 59 words, which is amazing. And that's the best I could find in my research. And it goes like that. So containerization is a trend that's taking over the world. Yeah, you probably all have heard about containerization. So that's pretty much true. It's a trend, and it's very important in our industry. And it's to allow people to run all kinds of different applications in a variety of different environments. That's the life we are living in our IT environments and with our applications. It's getting more and more diverse, using different operating systems at the same time, different development environments, different development languages, and it all should work like a charm. So we need something that can do that. And when we do that, they need an orchestration solution in order to keep track of all those containers and schedule them to orchestrate them. That's what I mentioned before. So it's getting pretty quick, pretty complex. So you need someone who helps you along that way, and that's the orchestration solution. And one of those orchestration solutions out there is Kubernetes. So and Kubernetes is an increasingly popular way to do that. And we agreed with that. That's why we based our solution on that foundation and using Kubernetes for getting it on the containers and handling containers in a very efficient way. So we're ending up with the third question. So why then manage Kubernetes? So if we have containers and we have container orchestration, which Kubernetes is one of the available and seemingly good solutions for that, why manage Kubernetes? Yeah, if you look at the picture, what you have to deal with, so you have to deal with infrastructure. Yeah, you get a provider who can help you with the infrastructure burden, and then you have the complexity involved running your applications more efficiently. And manage Kubernetes is just reducing that burden. So there are many components involved, and we're taking care of a majority of them. So it's basically a conversation about responsibilities, like in the cloud in general. So if you're using infrastructure as a service, platform as a service, or software as a service solutions, it's about responsibilities or who does what. And let's have a look at that in the context of container orchestrations. So what are the responsibilities for different type of solutions which are out there today? If we look at the plain Kubernetes, which many customers already run on top of Exoscale for some time, but why it wasn't popular with everyone is because of, if you look at all the stuff you have to take care of: administration, installation of Kubernetes, backup of Kubernetes, scaling of Kubernetes, provisioning compute instance for worker nodes, configuration of scaling of the application, deployment of the application. So there's a lot to do to provide this smooth service for application consumers. And managed Kubernetes takes away a big chunk of that burden. So the administration, the backup, the scaling, the provisioning, that also goes away. And there are many providers out there who provide services like that. We are now one of them. We are proudly introducing our solutions to that. And there are another stream already out there, which is called Serverless, and it's also available from different providers. It even looks more tempting because it takes away a lot of responsibilities. So there's only deployment of the application left, but it comes with some cost, not only real cost, which you see in the price line, but also the cost of not being able to run everything you could run in the other type of application environments. So managed Kubernetes, from my point of view, is the sweet spot today. And that's why we invested a lot in this kind of solution for you, because it's the optimum of having that expectation customers have towards applications and gives you a tool set which makes it handleable without being expert in every detail to run those applications to the expectations of your customers. So that's very important. And that's the right view you should have on managed Kubernetes. But managed Kubernetes is there's the container orchestration part, of course, but there's more to it. So to run containers, or the complete container lifecycle management, includes much more components. So you have to think about monitoring, your backup, your continuous integration, continuous delivery pipeline, security logging, and so forth. And this ecosystem, there are many called like plugins or options you can use in the Kubernetes ecosystem for doing all those stuff. And we are providing different ecosystems. Our ecosystem gives you a lot of choice that you can, or your team can decide based on their preferences, what you want to use for those specific tasks. If you look at our offers, so managed container orchestration ecosystems, as of today, we provide our own open ecosystem, because all the ecosystem decisions I just mentioned before are your decisions. So you can make it your managed container orchestration system with your preferences, but also with your knowledge and your expertise. You have to run it like that. Other options, which were around a little bit already and are available on the Exoscale marketplace, Puyo, from one of our partners, it has a pre-built ecosystem, so it's even more managed than our solution. So there's a partially managed ecosystem. And there's another solution, Compliant Kubernetes, which provides a full ecosystem for people who have to run their applications in a very regulated environment and have to take care of a lot of compliance stuff, which makes it even more complicated to run applications. But we have a solution for that as well. Together, we teamed up with another partner to provide this type of ecosystem on top of Exoscale. So what do we launch today? We launched today 2 packages, basically, a starter package and a pro package. From the usage scenario, so the starter package is kind of a freemium model. So it's free to use. It has all the features, so portal, API, CLI, Terraform interfaces. Target group is for developers or people who want to convince themselves using container and container orchestration. So they made a proof of concept, and so that part is not becoming too cost intensive. It makes sense to use these free versions. It's not for high availability production. There's no backup service included. There's no classic SLAs included in that starter package, but it's for free. You can use it with all instance types available on our platform. And for the pricing for the worker nodes, there's no overcharge. What does it mean? All the nodes you have to use, or you need to use in your environment, there's the normal price applied. There's no additional SKS fee involved. So that's good news as well. And That's our motto. We try and we love to keep it simple. The same is true for our Pro version, which includes then high availability functionality, backups of the very important etcd key value store, and our typical service level agreements, and a reasonable price for that service if you compare it to others. And of course, all the instance types and no overcharge on the worker nodes. Yeah, to round it up, I would love to give you some guidance, and that's always difficult, because if you go out and look for all the solutions in the area of managed Kubernetes, it's not really easy to make a pick. And that's why I want to give you a provocative text and a picture you probably keep in mind after that presentation. And I think it will help you to make your right decision, because if you give your customers everything you have in one place, it can be overwhelming or absolutely useless. We are all big fans of tools, and so we all also fans of Swiss Army knives. And to pick the right Swiss Army knife for you, it's not an easy decision, because you can have a lot of functionality. But if you came up with a Swiss Army knife like that, which was actually built and launched in 2007, and if you're interested in that particular piece, you can read the Wired article I mentioned. There's a link below. But on the other hand side, it's an impressive technology show off. But if you try to put that in your pocket and or try to use it, it's more in the category of absolutely useless, but maybe nice to put it on display. So you have to think about it. If you pick your managed Kubernetes, what should your Swiss Army knife look like, and how much functionality do you need, and how simple do you want to have your tool to make it at the end the tool to run your applications very efficiently and very available for your customers. And with that, I want to hand over to my dear colleague Dennis, who will take you on the next tour and show you more details and more interesting stuff, probably for the technical audience, on scalable Kubernetes service. Thank you.
So thank you, Hans. So I'm the more technical guy at Exoscale. I'm actually a cloud solution architect, and I'm not talking so much, so let's directly dive in. So on the right side, you see my console. It's actually the local console of my computer. And on the left side, you see the Exoscale interface. Let's directly start by just creating a Kubernetes cluster. For that, we will use the exo command. So you use the exo command with everything around Exoscale, like creating virtual machines, creating instances, and so on. So we start by exo SKS, Scalable Kubernetes Service, then create. Then I will give it a name. So my cluster needs a name, and I will just call it Dennis SKS. So that's my name. And I also have to specify how many nodes the cluster should have. So each Kubernetes cluster needs computing power, and as such, I must specify how many of them. So in this case, I'm just saying 3. And also, we need firewall rules for them. So basically, these are simple security groups, and I prepared one beforehand. And these security groups then say, okay, this port is open or this port is actually closed. And so I will just specify the one I created beforehand. So let's check, looks good. And let's create a cluster. So creating the cluster only takes around 2 minutes, which is usually very fast in the Kubernetes world. And while it's creating, let's take a look at the architecture again. So the first thing is, why do you need containers? Let's say you are programming in Java. And in the classical sense, you then go to your system administrator and say, hey, I have a Java app. Please install that for me. So I've programmed it, so please install Java on the servers. And then the system administrator may say, oh, I don't like Java. I don't want to do it. But this is no problem, because you can just take your application, whether it's Java, Node.js, JavaScript, or PHP, then pack this into a container, and then just give your system administrator the container. So he won't have to worry about dependencies. He will just need a container runtime. Docker, for example, is a container runtime. Also, Kubernetes uses container runtimes. So this is exactly how Kubernetes works. Kubernetes is basically your administrator in this case. You just give it your container and it will run it. In the Kubernetes world, containers are also called pods. Those pods in turn run on nodes. Those nodes in turn run on real virtual machines. So just on real Exoscale virtual machines. And this is the cool thing with a managed service. So everything is ready when you create your cluster. And then you can just really give your cluster, your containers, your application, and it will run it then. So really quite simple. And this is basically the sense of Docker. So when you use some host like Exoscale, which is a virtual machine host usually, then you will give it a virtual machine or boot a virtual machine, and it will then start it somewhere somehow. And the same thing is actually with Kubernetes. So, but you don't give it a virtual machine or some part of it or anything else like this. You will just give it containers, and it will then take care about booting up your containers, starting up your containers, and so on. Additionally, in the managed service, we also manage the network and so on. So you don't have to worry about this. And as we see, the cluster is just created. So let's also take a look into the Exoscale interface. And here we see instance pools. So I've just explained that the Kubernetes nodes consist of real virtual machine nodes. And those nodes are in turn grouped into instance pools. So we have here an instance pool, which consists of 3 instances now. And as you remember, I specified, okay, give me 3 instances. So this is done. The next step is I need somehow as a developer a way to connect to my cluster. So we just created it only. But this is also quite simple. So we go here again with SKS, then say kubeconfig. So to connect to your cluster, you need a kubeconfig. Then give it the cluster name. Then a name of the admin. So I'm using just my name. Then a time period, because in reality, this is a certificate and you have to specify a validity. And you also give it a permissions group. So in this case, for example, system masters, it has all permissions. Also, it outputs the config directly to the console, but I want to have it saved. That means I will save it in my home directory. So it basically now fetches such a config, and now this is ready. Accessing the cluster now is really simple. So you just need to install kubectl on your local computer, and you need to have this config ready in this directory. Now, everything with Kubernetes is started with kubectl. We can now use get. So get will list resources. And this time I want to list all nodes. And we see, okay, there are 3 nodes, just like this. And one of the nodes is not ready yet. So it just takes a bit of time until every node is then signed into the cluster, but we can just check again. And you see, okay, now it's ready. Now we're ready to go. And now we're ready to use our cluster. The next thing is in the beta to approve all certificates. So basically all communication inside of Kubernetes is encrypted and is of course authenticated. So in the beta, we need to approve those certificates, but after the beta, this will be done automatically. So let's say you have now your application ready. So you have now your container ready. How can I run it? Well, running it is actually quite simple. So I just say, okay, kubectl run. Then I will give it a name, for example, my shell. Then I will say, okay, let's make it interactive because I want you to see something. And then you have to specify an image. So usually you pack your application into a container. You then upload it to a registry, in this case, Docker Hub, and Kubernetes will download it from the Docker Hub then. Also, I'm saying, okay, please run a command for me inside this Ubuntu container, and it's just bash. So, and what happens now is Kubernetes downloads now this Ubuntu container and tries to actually run it inside the cluster. And we see, okay, we have now a command line, and this is now a real container. So let's exit it again. And because I didn't specify to delete the container afterwards, it will still run. So let's check the pods. So like I said, pods are basically containers in Kubernetes. Get pods and give me more information. Also, I'm enlarging it a bit. And you see, okay, this is the pod I just created. We see it's not very old yet. And it also got an internal IP address. So the communication is done basically also automatically. Also, it got assigned a node automatically. So I didn't specify any node. It just searched for a free node and then put this pod into this free node it determined. So this is really just a quite simple example of how to run a pod or a container. But let's say you want to have a more complex application. In most cases, Kubernetes dashboard is used for daemoning. So let's just Google that. Kubernetes dashboard. Okay, let's take the first result. And this is basically how the Kubernetes dashboard would look like. So there you can see all pods, you can see all nodes and so on. Quite a complex application. But the cool thing is, even when it's a complex application, it's not really complex to deploy it. So usually in the Kubernetes world, you have YAML files or manifest files. And in those files, everything is defined. So let's just scroll. Oh, we see here a comment. Let's just copy paste this comment. And we see things are created. Actually, resources are created. So I just said, okay, kubectl apply this time. So apply a file for me. And this file can also be hosted in a website. And then it creates some things. So for example, it creates service accounts, it creates deployments, which consist of pods and so on. So really some more complex application, but really easy to deploy. So to access this application, we need something else. So we need basically, for example, a port forwarding. So Kubernetes dashboard is not to be meant to be accessible publicly. So it's just for administrators. And for this reason, we need to somehow access this container directly if we want to open up this web page. And there's really a cool tool from Kubernetes. You can just port forward. So that means I will open up a local port here at my computer and forward it directly to a pod inside the internal Kubernetes network. So let me open up a new tab. And let me just copy and paste this command. So you can just copy paste it from the website. It's no magic. And basically you say, okay, kubectl, please port forward inside this pod, so inside there. And use the local port 7000, so the port 7000 on my computer, and this port in the pod. And we will get here a URL. So when we go back into the browser and open up this URL, what happens? Okay, it just says it's an HTTPS website, so we probably have to write HTTPS there. And it's using a self-signed certificate, so we will just accept it. And then we basically see the application. Of course, also the application has some kind of authentication, and authenticating yourself is also quite easily. So basically you copy paste also comments from the Kubernetes dashboard. And what they just say is, okay, please create me a service account. Please create me a cluster role binding and give me a token out from it. So this, what I just pasted into it, is really just copy pasted from the Kubernetes dashboard website. And it will give me a token. I can copy it and then insert it. And now we see the dashboard. So really quite easy to deploy. So for example, we now see the pods and we see, oh, there's my pod from before, my shell. We also see on which node it's running. So basically what the dashboard does is giving me the same information as typing get pods, for example. And this is really the cool thing with a managed service. Everything is ready to use. So you can directly just deploy applications like the dashboard. Of course, you could say, okay, the dashboard, well, it's no real application. But I actually prepared a real application. So let's look inside my folder. And I've created a YAML file there. Let's just apply that. So applying that is actually the same as with the dashboard. And we see different things are created. We also see new things in the dashboard. So we see, okay, a deployment is created and a service is created. So a deployment just consists of multiple pods, or basically you could say, okay, you want to have one pod, the same pod, but multiple times. So for example, you have your news website and you want to load balance it. That means you can put it into a deployment and you can then run it multiple times. Also, we have a service. So when we look again into the diagram, we access the dashboard directly via port forwarding. But of course, you need some way to access your services from externally, like your websites. And this is where services come into the play. So services are just load balancers. They give you an IP address, an external IP address you could actually use. So let's check that. So we type in again kubectl, then get, and get the services. And we see, okay, it's a website service. It's a type of load balancer. It got an IP address, an internal IP address, but it got also an external IP address. And it's done that fully automatically. So this is also the advantage of our managed service. Something like load balancers and something like IP addresses will be done automatically. When you use Kubernetes on premise, you would have to do it differently. It would get practically much more complicated. Also, we can take a look at the pods again. So with more information this time, and I need to enlarge it. And then we see new pods. So 3 new pods. I called them website deployment, and they are running. Each of them got an IP address, and each of them is assigned to a node. So, okay, let's look into the source code of this application. Or first, let me just show you this application. So we just take this external IP address, then go back to the browser, and then open it up. And then we see, okay, here's my application, here's my website. It also got a host name. And when we compare it with this view, we see, okay, the host name is actually the same as one of the pods. So what I have done here is I accessed the IP address of the load balancer, and it automatically routed the traffic to one of the pods. Now let's take a look at the source code. And the source code is really quite simple. So at the topmost part, we have the deployment, and at the bottom part, we now have the load balancer. So Kubernetes files, so this is one Kubernetes file, you could say, consists of YAML files. And here we define, okay, kind deployment. We also give it a name. And a very important thing, a selector. We just call it website app. Also, we define a template. So the template will consist of a container and also use the same app name. And there is now the magic. So this is basically the heart of the pod. So we give it a container. And what I have done is, before the webinar, I quickly programmed our application. So it was the application you saw on Firefox. And this is written in Node.js. And I've also written a Docker file where I've written, okay, please make as a requirement Node.js, and please copy my application into this container. I also took this container and pushed it to the Docker Hub. And this is basically the URL of the Docker Hub. So I could theoretically also write directly dockerhub.com, for example, and then / and then the URL to my container. So Kubernetes, when it sees that, it will automatically download the things from Docker Hub, for example, or any other registry. So you can also specify something else. You can also specify authentication and so on, and then will attempt to run this container. Also here, I specified, don't run it only one time, but run it multiple times. And in this case, run it 3 times for me, please. And now comes the cool thing. So this is the service at the bottom part, and it also has a name, of course. But I also specified the location. So in this case, Frankfurt. And here comes the selector again. So this is actually the same selector as there. And this is now the real cool thing in Kubernetes. You don't work with IP addresses or with any networking stuff. You just write names. And what happens here is that Kubernetes creates a load balancer, and it will route traffic to this name, basically. So it seems, okay, there are pods which have this name. And so let's route traffic from the load balancer to the pods directly and don't use any stuff like IP addresses. Also, I have to specify ports. So in this case, HTTP, so not HTTPS, but you could do this too. And the target port, which basically needs to be the same as the container. So, and when we go back to the terminal, you could maybe say, okay, but I have a large news website, and what happens if we get breaking news? Well, then you can easily scale your pods, actually. So you can just say, okay, kubectl, scale, then you give it the replicas. And now we don't want to have 3, but 6 replicas. Also, we give it, of course, the name of our application. And it will now try to scale this application. So when we take a look at the pods again, we now see there are actually 6 pods and not 3 anymore. So we just started them. Also, we could try to refresh actually this website. And we see we always land, or not always, but with some probability, land on different pods. So the load balancer automatically routes traffic to different pods, and then we will land somewhere else always. So let's take a look back into the Exoscale console. So we just saw this node pool. I will just refresh it. And we had 3 instances. But let's say you need more computing power. Well, this is easily done. So you just write exo_sks, node pool, then scale, then the name of the cluster, then the name of the node pool, which is in this case the same as the cluster, and then a number, for example, 6. And then it will automatically scale the whole cluster or the whole node pool. So we see it was 3, but now it's 6. So it's actually booting up additional instances. And this is also done fully automatically. So you just say you need more instances. Those instances are booted, they're initialized with Kubernetes, and they're also automatically signed into this Kubernetes cluster. So you don't have to do anything more. We can also take a look into one of the instances. So we just click inside the instance pool, and then we see some information. For example, okay, how big is the disk size? What is the zone? And we, of course, then see the instances itself. So each one got an IP address, of course, and we can click on one of these instances. So we see these are just real Exoscale instances, just normal ones. And they also have a type. So each one has 2 vCPUs and also 4 GB of RAM. But let's say that's not enough. So let's say you want also some different kinds of node pools. Well, then you can just say, okay, SKS node pool. Then give me a new node pool to my cluster, then it's SKS. Then you will just have to use some name like node pool 2. Then give it an instance type. For example, is the instance type large? So we used medium here. And you will also have to give it a security group. So security groups, like before, are just firewall rules. And then we can apply that. And we see there's a new node pool booting. So let's take a look into the list again. So instance pools. And then we see just a new node pool actually appeared. And like I said, everything is done automatically. And it's also automatically signed into the Kubernetes cluster. So let's also click into it and into one of the instances. And then we see, okay, this time it's really a large instance. So we now have different kind of nodes inside the cluster. Also, we can, of course, execute kubectl get nodes again. And we will see more nodes. So the other three were already ready. So the new node pool takes a bit of time. So I think like 1 minute, and then it will be ready too. But what about high availability? So when we take a look at the pods again, we see, of course, nothing changed because we didn't do anything with the pods. But what if actually one of the nodes failed? So for some reason it fails. So what happens with those? Let's just do this. So SKS node pool, and then just evict one. So yeah, I'm using the cluster name again, then the name of the node pool, which is the same in this case. And then let's just take one node. So I don't like this node, so let's take this one. And yes, I want to really do this. So this takes a bit of time, I think around 2 minutes. And then this node will be gone. So basically, it's the same as if the node had any failure. The interesting thing is then what happens there. But in the meantime, let's go back to the diagrams. So like I said before, most of the services are managed. That means when you write exosks create and then get your kube config, your cluster is ready. You don't need to deploy any networking stuff. Actually, Kubernetes uses networking plugins, but Kubernetes deploys a networking plugin for you. But of course, if you're more advanced, you can also say, okay, please don't deploy anything for me. I want to do the network plugin myself. Then you can also do this. So you're really flexible in this case. Also, other things are managed, of course. So the API server, which is of course mandatory for a Kubernetes cluster, and the etcd database. So basically, when you want to create your Kubernetes cluster on premise, you would have to boot up those services, configure all the services, also configure networking, and you would also have to take care about your worker nodes. That means you would have to boot up every worker node. You would also have to do this if you want to do some scaling. And you would then have to go into this worker node and sign this worker node into Kubernetes. But of course, there are much more parts. So this is really just simplified. You would also have to take care about certificates, about encryption and authorization, and so on. So really about a lot of things. But in this case, you basically get everything ready. And we see, so the one node is evicted. So this took a bit of time because actually it tried in the background to do some jobs like shutting down the VM gracefully. But like I said, for Kubernetes, this doesn't make any difference. So a power outage would basically do the same thing. I'm just forcing it this way. And this takes a bit further time. So I think like 20 seconds and so on. And then let's see what happens. So I actually evicted out this node And when I see it correctly, yes, 2 pods are running on this node. So let's just check it again and see what happened. And we see, okay, it's gone, but there are still enough pods there. So what happened there is it actually noticed that one of the nodes was down and it reschedules those pods. So I specified, okay, give me 6 pods. And as such, it tries to stay up with this number. So there will be 6 pods always in the end, even when there is a failure. And we just saw, okay, there are new pods booting, and these were those pods which were down because of a failure. Of course, also the load balancer notices it and then routes traffic automatically to those new pods. So this was basically the technical part of the webinar, and I hope it was easy to understand.
So I would like to introduce Philipp Möller, who's a colleague of Dennis, and he will give us some really cool insights about the voices from the beta
So I hope you all can see me. And the SKS offering was quite some time in development. We've went the road in the direction of the release today, and quite a good portion of that road we've been accompanied by our alpha and beta testers. And actually the first feedback from myself and from us, from the team, we would like to give you is thank you. Thank you very much for spending the time with our product to improve it, to test it together with us. And we've actually achieved an outstanding over 300 hours of testing registered from all our alpha and beta customers. We also received honest feedback from you. And with honest feedback, I mean, we received critical feedback. We really received feedback that allowed us to forge the SKS offering to the market, to improve it and align it to the market demands, to your demands. So thank you very much for participating in the alpha and in the beta testing. To give you a bit of insight what we actually did with your feedback is, so we had a continuous development running where we got your feedback, consolidated your feedback, then directly went into a discussion with the backend team, with the developers. And we discussed the different feedback, the different challenges, and those led to decisions. So we prioritized, we made decisions how to implement, how to change the offering, how to align it better to your demands. And then we directly went to the implementation. And the SKS offering did see a lot of deployments during the beta phase. We actually started the alpha in August 2020. We started the closed beta in September and October, and we had several, I cannot count them anymore, deployments of SKS to adjust to bug fix the service. So actually, I would like to give you insight into two voices of two of our customers. So the first is Infinite Devices, with us from the very beginning, from the alpha state of SKS, started in a very bespoke and manually deployed SKS environment to test their open source IoT platform InfiniMesh. So the feedback we received from them was very good because it was quite easy for them to get InfiniMesh as an application running on SKS. The CLI was easy to use. It was easy to deploy. So what we found out is that for the productive environment, they require ethereal storage to be available for the nodes, to store data across different pods or accessible for different pods, even after recycled node supports. And this is currently not available in a managed fashion because Infinity Devices wants to have the same ease to access and the same easy deployment and utility of the managed storage than they have for the SKS offering. The second was the integration into the load balancing service. And as Dennis just showed us or demoed us, this is already there. This is already implemented. So why does Infinity Devices went with us into the alpha and the closed beta? That's mainly because their platform is used for government, healthcare, and defense as well. So compliance, especially GDPR, is a must for them. Additionally, Infinite Devices quite likes the mentality of us. They're not a number in the big pool of customers like they are with the hyperscalers, but you have a personal contact. You can talk to somebody and actually get to the point of issues and challenges and find a solution together. So the second customer is the Instant Solutions, OG. Instant Solutions actually develops apps and cloud native applications. So they really develop in Kubernetes and for Kubernetes, which is very good in the current market. Additionally, they also offer a full package, so a managed hosting for the project, so their customers get the development as well as the hosting for the application or the web application from Instant Solutions. And there they're looking for SKS as an option to actually, easily host those products for their customers. And the feedback, we received a very good quote. We always look for a service like SKS based in the DACH region. We are excited to establish our offerings in a compliant environment and cannot wait to start the first projects on SKS. That's for David Andlinger, who's the managing partner at Instant Solution OG. So the main criteria again was the GDPR compliance, as well as the easy to use API interface and the many integration into DevOps tools were very welcome because it makes the deployment with and into SKS quite easily. So for the finishing words, I would like to hand over to Antoine again.
Hello. Thank you everyone for the demo. So yeah, today the announcement is that we launched today with SKS. It is in limited availability in Geneva, Vienna, and Frankfurt. So product is to be used today. What does this mean? If we forecast general availability is targeted for mid-March, what does that mean? That means we'll gradually launch in all zones and also make the full web portal integration. So currently you have API and CLI like we demoed available. Terraform provider is also being worked on and very close to be released. And of course, we'll enforce fully our SLAs on the products. We'll be getting CNCF conformance also on SKS. This is under review by the CNCF committee. So from now until GA, starter and pro versions are free for all, and then once GA is achieved in all zones, we'll start charging for the pro version.
First of all, thank you, Antoine, Hans, Dennis, and Philip for the insights around KS. We received, as I said, a ton of questions, but as we still have 25 minutes left, we might not manage to answer all of the questions. However, we would like to stay in contact with you and try to answer the remaining questions separately afterwards. So the first question which came into the chat was, could you provide more details on the differences between SKS and the other Kubernetes offers from the Exoscale marketplace?
Yeah, sure. But I mean, I'll also invite my co-presenters to join me. I'll take the first one. So like Hans showed in our slide in the lineup, the difference between the versions of Kubernetes is really the ecosystem. SKS gives you the choice of everything that lies on top. So you want to, most likely as a team, you might have your monitoring engine. You might have a system only for logs and etc. So you can just plug that into SKS and have your full environment running for development and production. With the other products from the which are in the marketplace, choices are already made for you, and they come already bundled. For example, with the compliant Kubernetes, already logs and monitoring solution are included.
Thank you very much. The next question is there any way to retrieve Kubernetes connection credentials using Terraform?
So I'll take this one as well. So the provider doesn't allow you to do that, and our position would be that it might not be the best way to do it. I mean, the kubeconfig has a secret there, so that might not be the job of Terraform. More something to do with the key management, Vault. Also, if you want to stay in the HashiCorp ecosystem. So no, our provider will not have a way to retrieve it, but it's a good question. We'll look into how all this ties in together, so that we can give a seamless experience. That's to be worked on.
Thanks a lot. The next question is there a way to migrate an existing Exoscale infrastructure that use load balancing with elastic IP to the new model with SKS?
Complex one. I understand that the person has already a load balancer or elastic IP. Elastic IP will be tricky if the person has already a load balancer. Denis, do you have a highlight here?
So for your infrastructure, you definitely would have to also write the Kubernetes files, so like the manifest I showed you before. And actually, the load balancer I showed you in this file is actually the same load balancer as used on Exoscale. But it's not yet clear whether you're directly able to migrate this IP address from the load balancer without Kubernetes to the one with Kubernetes. But we can then answer this in detail after the release.
Thanks a lot. The next question is, where do you see the load balancer that is automatically created in the Exoscale dashboard? And does this incur any additional costs?
I can maybe answer on the cost question. Well, maybe Denis can, if you can share again. I don't know if that's possible. So the cost, yes. I mean, SKS will automate different parts of the Exoscale infrastructure, like we said. The instances and the load balancer are running at the standard rates. So if you use 3 VMs for your node pools, I mean, those will be 3 VMs charged at the default rate. If you use 1 or 2 load balancers, those will be load balancers at the standard rate as well. So Denis, do you want to show maybe?
So yes, so this load balancer I didn't create manually. So this was actually the load balancer I created in the presentation, and it's still online. I didn't destroy it. So we can take a look here. So basically, this is the IP address of the load balancer. So when I copy this, it's actually the same as here. So of course, I will get the same page. So we see this is really just the real Exoscale load balancer, which is automatically created inside Kubernetes without doing anything here.
Good. So the next question is a little bit longer. So where are the specs for pods defined? Let's say the web server needs at least 512 megabyte of RAM and 2 CPU cores to run the web server properly. OS, Docker overhead not included. I just need to scroll. How would you enforce this? What happens if the nodes run out of resources? Can we start another pod then? Or is there some notification information for the situation? And there's a thanks again.
So Kubernetes basically tries to create a huge cluster, and as such, you have ways to define the resources of pods. So I've shown you before the manifest file, so this source code basically, and there for each pod, you can exactly define which are the resources of this pod. So you can say, okay, this pod needs 2 CPU cores and it needs like 2 GB of RAM, or maybe even more, maybe it needs 12 GB. And as such, Kubernetes has a view of all the nodes in the cluster, and it will try to schedule those pods where resources are free, of course. If this would fail for some reason, you could look it up into the kubectl logs command, and you could probably also forward this information somehow. So basically, Kubernetes tries to automate all those things and also tries to automate scheduling. Of course, you could also say this pod needs to go to a specific node or to some specific nodes. This would be possible too. So basically, everything is possible. You just have to define it.
So there are no limits.
No limits, and that's really the job of Kubernetes itself. So here we, as Exoscale, we don't add anything or remove anything from the plain Kubernetes experience. What you could do as well is, have some sort of auto scaling in play, and because there's automation between Kubernetes and the underlying instance pools to scale horizontally as well. So that's a way to address resource limits.
Yeah, so actually you saw before how I manually did scaling, but you can also automate all those scaling things. So if you run out of resources, you just automate it and it will boot up new instances.
Yeah.
Thank you. The next question is a short one. How do you estimate the number of pods per node?
So actually, Kubernetes does the estimation. Of course, I'm not sure what the question means. So you can, of course, show the pods inside the nodes, but Kubernetes all does those estimation, how many pods to schedule on one node by itself.
Good. The next one is persistent storage also supported?
Yeah. Good question, and thank you to the person asking. So we introduced SKS as a plain Kubernetes experience. The storage solutions are the ones that currently are supported on Exoscale, meaning that you can, of course, rely on the local storage. So use the local storage of pods. If your application design is compatible with that, it's something that you can use. It's by default in Kubernetes, you can rely on this. For any type of, more file assets, we of course would direct you to our object storage, which is F3 compatible. So that's an easy way to put data there. If you want block storage directly attached to your cluster, we don't have this embedded, and not at the moment. So solutions like software-defined storage solutions that can rely either out or within the cluster, namely Longhorn or OpenEBS or Linstore are solutions that run well on SKS.
Thank you. Next question is there any best practice for application that requires a database?
Difficult to take that one on without context. If it's on the general Kubernetes related or really specific to SKS, I don't think we
so like I said, Kubernetes is just a container host. It's like Exoscale is a virtual machine host. So you have to define yourself how you do the networking, and it highly depends on the database, whether you use some cluster database like Cassandra or some database like MariaDB. But the good thing is Kubernetes is also really a buzzword. So you can just Google your database and Kubernetes, and you will always find some example configuration for Kubernetes. And then you can just take this and try this one out.
But the usual setup is that you most likely have already a running database. Okay, if that database is running, you can expose that database as a service to your Kubernetes cluster, and then consume the database from any pod that's running within that cluster. That's one way to do it, but that's plain standard Kubernetes setup.
Yeah. So you also saw in my example how I connected the load balancer with a pod or with multiple pods, and the same you can of course do with databases.
Thank you. The next question is, how does monitoring and logging looks like? Is there a managed version and is it persistent?
So there's no out-of-the-box tool for logging managed by Exoscale, but you can basically just install many open source solutions for that and then define it yourself. And of course, you can also then make it persistent or even with something like push notifications.
Next question is, can I put a Kubernetes cluster together with a normal VM in the same network to communicate on an internal network?
So this is rather difficult. So of course, you're free to deploy your own network plugins. And basically, you can create ingress controllers for that, which will connect with your application on the outside. So basically, everything is possible with Kubernetes, like on every classical infrastructure. So this would be possible too. But of course, you would have to inform yourself of how to do it and how to connect those things.
But our security groups will allow to do this quite easily as well. So nesting a group with another, if that normal VM is another group, then grant access to and from the workloads in the Kubernetes cluster.
Thank you. The next question is, you see we have a ton of questions. How do we translate a standard Exoscale managed private network into the SKS system? Is there a tool to do a migration?
You saw in my application that Kubernetes does networking by itself. So it comes with an internal networking, all the services talk internally. So migrating directly maybe makes not so much sense. So you basically define your pods, you define your infrastructure, and you give it names. And with those names, you're actually able to communicate with each other. And internally, it uses an internal network. So it's just internal, it's just a own network inside Kubernetes. And as such, you have a whole different network. And you must, of course, then configure it with the Kubernetes tools.
Good. The next question might be the same topic as before because Terraform is in it. Is there an ETA for the Exoscale created SKS Terraform support?
Yeah, I won't commit to a specific date, but it's already well in the works and will be released very soon.
Thank you. What kind of operating system can be used within your containers? Linux and Windows? Question mark.
So Linux only.
Yeah, it's just Linux. Yeah.
So I think there are some repeating questions, but I hope I don't miss anything. Is there an easy logging solution available? Cluster logging.
So actually, there are some easy solutions. So afterwards, we can also, of course, send you some links. So basically, you saw how I deployed the Kubernetes dashboard, and there are some applications which you also just can easily deploy, and then you have a solution ready. Of course, some configuration will always be needed.
Good. So I'm taking the last question because we are a little bit running out of time. Last question might be interesting. Are easy monitoring stats solutions available, e.g. Prometheus, Grafana, and so on?
Yes, so you can actually just Google that. So I Googled just the Kubernetes dashboard, and then I found a manifest basically. And the same is also true with all those popular applications. So usually those applications themselves provide such files, so such manifest files where everything is defined, for example, everything Prometheus needs. And then you can just take this manifest, maybe adapt it a bit if you need some kind of different features there or different configuration there, and just apply it to the cluster. So the steps are actually quite similar.
Let's take next one. Can we expect Rancher integrations?
can we expect? I didn't get it.
Rancher.
Rancher.
Mm-hmm.
So of course we'll be opening up to all our, existing and new partners as well. So SKS is open for integration. We had previous Rancher support for Exoscale, so Rancher was able to create and deploy automatically Rancher managed Kubernetes. Having Rancher integrate with SKS natively and manage it would be a great addition. And we are already also talking with other Kubernetes sorry, application dashboards, people like Appvia and etc. trying to build support for SKS within those tools. So open for any integration. However, this is not something that we will build ourselves. We need to work along with the partner for this.
And
so
maybe
one last, sorry.
Wait, maybe in addition to the other questions regarding metrics and so on, we also have a blog where we will publish tutorial articles like how to install block storage and so on. So make sure to check this blog, and there we will provide step-by-step tutorials on how to install things on Exoscale and maybe even metrics later and so on.
Thank you. So one last shot. Are you also going to launch shared block storage to have a persistent storage for pods moving throughout the SKS?
Same as before. Our first answer here will be to publish very detailed how-tos on how to do that within your cluster and bind the storage with your pods.
Thank you very much. So I'm closing the Q&A, but to all our participants, we gathered all the questions and we will follow up the questions which are not answered in the Q&A. So you will not get lost, we will contact you. So many thanks to our speakers and their openness in answering the questions. Likewise, many thanks to our numerous attendees. A final note before we close, you will receive tomorrow during the day the addressed documents and the recording by mail. Also the code you have seen in the live demo from Dennis. So on that note, I wish you a pleasant rest of the working day and see you soon. Thank you for your attention and have a nice day.
Bye-bye.
Bye.
Bye.
Thank you. Bye-bye.